So in this video we're going to look at critical points in partial derivatives. Now I'm just sort of separating this from the subsequent videos just for the sake of brevity. So just have a shorter video. Now the point AB is called a critical point of the function f of x and y. So we have this point AB. If both partial derivatives of f, both with respect to x and with respect to y at the point B, are equal to 0. Okay, so the differential of the derivative of f with respect to x, the partial derivative of f with respect to x, and the partial derivative of f with respect to y at the point AB if they're both equal to 0. So it's a straightforward enough definition. It's quite important. There's a couple of tests that will follow on later on with respect to that. Are they local maximum, local minimum, or saddle points or something like that? I'm going to save that for another video, but for the time being, we'll just sort of stick to critical points. So this is a sort of key definition. This is where you sort of start off. You would get your function and get the derivative of it with respect to x and with respect to y, and try and deduce where a and b are. So find the critical points for the function as follows. F of xy equals x squared plus y squared plus 2x minus 4y minus 4. So this is simple enough one just to get started. So derivative of f, partial derivative of f with respect to x, that's equal to, well, we have x squared there, 2x plus y squared, that's 0, plus 2x, so okay, plus 2, minus 4y, 0, minus 4 is 0. Derivative with respect, partial derivative with respect to y. Let's change the pen color there so I can cross that out. There we go. Something similar. X squared, derivative of that with respect to y is just 0. Y squared, we have 2y. 2x, never mind that. Minus 4y, well, minus 4. And again, the minus 4 derivative of that with respect to y. That's just constant, so that's 0. So, to find the critical points, what we have to do is let both of these equal to 0. So, 2x plus 2, that's equal to 0. It's a sort of, you might sort of figure now it's a sort of pretty easy one in this case. 2x, let's go to the next slide actually. There we have it there. 2x plus 2 is equal to 0. 2x is equal to minus 2. So therefore x is equal to minus 1. Likewise, 2y minus 4 is equal to 0. 2y is equal to 4. Y is equal to 2. So our point that we're looking for in this particular example is simply minus 1 and 2. Oops, let's do that again. It's minus 1, that looks like a 4 there. Sorry, I was just trying to put in a bracket. Minus 1, 2. Okay. So, what would... there's a couple of tests you might go further with. For example, is it a saddle point, is it a local maximum, local minimum, and so on. I'm going to sort of save that for future videos just because this is 4 minutes and I just sort of can say critical point. So, okay, that's a critical point. 2x, or let the derivative, let's go back there to the start. There we go. That is the, let both the derivative with respect to x and the partial derivative with respect to y, let them equal 0 and try and deduce a and b. Okay, let's end that there.